Welcome back. So in the last video we covered R2 score. And so in this one we're going to look at mean absolute error. So let's come down here. We'll create a little heading. Mean absolute error, aka MAE. Now again, we could always look up what mean absolute error is, but what we're going to do is check it with the code first, and then we'll look into it. How do we calculate it? Mean absolute error. You might be able to deduce from its name what it actually does. If not, that's all right, we'll look into it. Import mean absolute, nearly did square error, that's going to be the next one. To evaluate it, we need to make some predictions because remember, evaluation metrics are always comparing truth labels to predicted labels. So we'll predict on the test data set. We'll go MAE equals mean absolute error. And we're going to compare y-test, which is the truth labels that we made up here, y-test, to our predictions, which is what we've just made here. And then we're going to have a look at MAE. Okay, that wasn't too hard. But 2.12, what does that mean? Well, again, this might be a little bit easier to visualize, right? So we might create a data frame. Side by side, we're going to pass it data equals a dictionary, and we're going to have actual values versus what we want here is predicted values. We'll go y preds. Wonderful, and then we'll have a look at df. So what do we have here? Well, this is the truth labels. This is what our model has predicted. So we can see 23.6 is 23.002, okay, 32.4, 30.8.2. Looking at these, right, and then looking at this number, can you think about where this number might be coming from? That's all right if you can't. What we might do is add another column that may add a little bit of clarity. Equals, and we're going to do df predicted values. So this is a column we're creating for the differences, right? So the difference between our predicted value and the actual values. There we go. Then we'll view df again. Differences. Okay, so we see that this one is minus 0.6 or so. This one is minus 0.5, and this one is 3.1, so it's a fair bit off here, and this one was really off, right? It's minus 4.87. Okay, so now you might be starting to get an idea of where mean absolute error comes from. If not, mean absolute error, it's formally defined as the average of the absolute differences between predictions and actual values. And so it gives you an idea of how wrong your predictions are. So what we might do is write that here. So MAE is the average of the absolute differences between predictions and actual values. It gives you an idea of how wrong your model's predictions are. And what it means by absolute is that it would turn these values positive and then add them all up and then take the mean. And then that's going to give us this number. So basically, what this is saying is that on average, every prediction our model makes is going to be on average plus or minus 2.12 away from the actual value. And you can kind of see that, right? Some are only 0.667 away, but others are more than 2.1. So this is 2.89. And this is negative 3.794. And you could keep going throughout all the 102 rows and figure out this figure manually, or you could just take the Scikit-learn implementation's word for it. So what we're going to do next, that's covered mean absolute error. We're going to have a look at mean squared error.